It's time for Pure Performance.
Get your stopwatches ready. It's time for Pure Performance with Andy Grabner and Brian Wilson. Hello, everybody, and welcome back to another episode of Pure Performance. My name is Brian Wilson, and as always, we have with me my co-host, Andy Grabner. Andy, how are you doing today?
I'm pretty good. How often has it happened that you introduced myself and kind of saying I'm here and I wasn't here? Has it ever happened?
That I'm here?
Did you? Yeah, you always say, "Hey," and with me, my host, and then you don't even know if I'm here.
Of course I know you're there because we, why would, I mean, sure, this is the kind of argument my daughter makes with me, like anything can happen, you could suddenly, disperse or disintegrate, even though I was just talking to you. The next second, you might no longer exist. There might have been a blink or a Thanos event or something. Yes, that could happen. But if it did happen, I think I would have a little bit more to be worried about than the fact that I went to introduce you and you suddenly weren't there, Yeah. So I take it for granted. You're right. I should never take anything for granted. I'm just so happy that you're always there for me, Andy. You're always there supporting me.
And I'm happy too, because without you, this would not be recorded and wouldn't make it out to the World Wide Web so people can listen to it. Now,
well, you would record it on Zoom, on regular Zoom, and it would sound terrible, but yes.
Hey, speaking of which, things that people can listen to. So we have a new guest, a first timer.
Yay.
And I wanna introduce him. Well, I think the best is for him to introduce himself, but I just want to give some background on how we know him. I was lucky enough to be invited for Neotys PAC earlier this year in Santorini, where a couple of performance engineers got together and talked about performance engineering stuff. And Joerek, he was there, and he talked about some really cool stories from his large-scale load testing projects that he has done. And it was so fascinating, all the lessons learned about his major projects, that we said, let's get him on the podcast, and the whole world, all of our listeners should hear what to watch out for in case you run those really large-scale load tests.
I think it was extreme load tests, right?
Extreme load tests, exactly. Yes. So, Joerek, do us a favor. First of all, thanks for joining. Introduce yourself, who you are, what you're doing, what your background is, and then let's jump into the topic.
Yeah, thank you, Andy. Thanks for the invite, by the way, for this podcast with you. So it's been a pleasure. Well, I am Joerek van Gaalen. I'm a self-employed performance tester, and I've always been a performance engineer for the last 15 years. Mm-hmm. So, always been around in the performance part of the world, actually. Actually, since I started with performance testing, I've always done short-term projects most of the time. So I've seen a lot of different smaller projects. So I think I've done more than 100 different projects, which is cool. And the last of them, I've done a lot of large-scale performance tests. Mm-hmm. So that was also the talk of me in Santorini.
Yeah, and actually I remember now looking at the page on the Neotys website, the Performance Advisory Council. Yeah. We, the both of us, we were not only in Santorini, we were also at the inauguration event back in 2017 in Edinburgh, correct?
In the castle.
Yeah, that was cool, in the castle.
Yeah. I gotta admit, can you quickly remind me the topic that you talked about back then?
That was more or less the topic back then in the castle, where we are in kind of guarantee basically, like
Yeah.
now. But the topic, I have to remember what it was. Yeah, the topic was about the changing role of the performance engineer. So usually the role was always like, hey, you're a performance tester, so you do your old-fashioned way of performance test. And I was talking about not only the shift left, but also the shift right. So there was a lot of things as a performance tester, performance engineer that you can do. So not only testing, but also being part of production, monitoring in production, looking into that, doing the capacity management, also helping the developers. So on the left part of the pipeline, helping the developers with their performance challenges, etc. So a lot of more stuff that you can do as a performance engineer. So I want to shine a light on everything that you can do and being more like a performance specialist rather than an engineer.
Now, coming back to the by the way, the presentations are all online. So in case people want to look at it, check it out. Go to the Neotys website, go to the Performance Advisory Council, find Joerek's picture, click on it, and then you get all the presentations. Now, coming to the large scale extreme performance tests that you've been running recently, I remember that the one example where you were running a 2 million virtual user test or concurrent user test for a TV show, right? Can you give us a little bit more details on that? What?
Yeah. That's correct. Yeah. I've done a 2 million concurrent virtual user performance test, and it was for a TV show. And actually, the project management asked me to talk about some performance tests that they wanted for their project. And they started, we would like you to do a performance test. That you do it, and we expect 2 million users. So we should be able to verify that the platform is able to handle that load. So the first thing you think of, okay, 2 million users, sure, you're probably talking about registered users or total visits on a day, because that's what you see often, right? Talk about the expected load. They tend to give too high numbers. But then they were talking about the project and they say, okay, it's for a TV show. It's for a live TV show where people should start voting. We expect 2 million votes within 7 seconds. And that's what the application should be able to handle. So it was truly, they wanted to see 2 million concurrent users voting for people, contestants actually, that get on stage. And at the second they get on stage, people have to vote on if they should pass or not pass. So that was actually the test. It was cool because then we did the test with Neoload and asked them for a license for 2 million users, and they were actually say, "Hey, we never have done this. We can't even generate the license because the maximum number of users we can select is 1 million." So they actually had to change their backend systems to be able to generate a license of 2 million users.
That's awesome.
So that was also a fun fact, actually.
You were stretching the boundaries of your load testing vendor. That's pretty
cool. But what's interesting is they didn't say no. They probably said, "Oh, this sounds fun. Let's do this."
Yeah, because they also know that it's a nice challenge to have it. It's a good it's cool to say that your tool supported, but also I thought it cool to do it. So it was like a challenging project.
It's a free load test of the load tool.
That really was the case, because we had found a lot of feedback for them to improve. Of course, yeah. Because you see stuff that you will never found out.
Yeah. So what's the trickiest thing for such a project? Because obviously this is a testing for a one-time event, and it is, I mean, it's infrastructure for that test just for, the time of the project. Probably for, I don't know how long did it take you to kind of set it up to make sure that the test infrastructure is there, that they actually figure out what is the test infrastructure? I think that's probably a challenge too. How much test infrastructure load generators do you need, and things like that?
Yeah, of course, the biggest challenge for such a test is just to be able to generate the load, right? To have the capacity to generate the load and not being the bottleneck yourself, because that would be kind of ironic, right? If you do a performance test on an application and you are the bottleneck. Mm-hmm. So that was the biggest challenge, to have sufficient power. And also what I wanted to do to make the challenge even more challenging is to run the test from a single controller. So I didn't want to duplicate, let's say, 8 or 10 different controllers and hit the start button all at the same time and then gather results later on. I also want to be the challenge that it was possible from a single controller. And the test setup was like, we had, I used 800 load generators. The load generators were able to simulate up to 3,000 concurrent virtual users on the application. So I was fine with, 2,500 on a single load generator.
Okay.
So, for that to happen, because you need to know first what can a single load generator handle in the test. So then you know how many load generators you actually need. So I first did the stress test against the application with just a single load generator and see how far I was able to come. And that was about 3,000. And at 3,000, then things starts to get itchy. It starts to slow down, response times get, the agent become unresponsive, weird things happened. So I set a safe limit at 2,500 would be kind of okay.
I remember, just to jump in here, I remember before Dynatrace, I used to work for Segway Software, which later became Borland. We did Silperformer, right?
Silperformer,
Yeah. And I remember we had a feature in Silperformer, this was like at least 15, 20 years ago now, where the controller monitored the health state of the agents and also gave you recommendations. So you ran a script, and I'm sure they have advanced this over the years now. It's been really 15 years since I've been there. And the controller gave an overview of all the agents and gave recommendations on how many scripts you can safely run, how many scripts of that particular type, or how many virtual users for that script you can safely run before the agent gets into a mode where the agent itself is impacting the test results.
Yeah.
So I think that's obviously something you have to consider if you're running these large-scale load tests. You don't want your test infrastructure to be the problem, and that could either be the load generating agents, but I guess also the network bandwidth that you have from your load generators to your application that you're testing on.
Yeah. Well, Neoload has some kind of features to look into the current system resources of the load generator, but it doesn't actually give you a lot of advice up front on how it's behaving and how many you would need for the test. It would be a great feature, by the way.
So what else? So that means you started with figuring out what's the capacity of a single load agent, then you could do the math, and you said you came up with about 800 load generating agents to cover your 2 million number. What else is there? I mean, this is obviously some important preparation step.
Yeah, there are a lot of preparations actually to do, and also a bit of the approach, because there are some levels actually on the test that you have to kind of tune, because you can tune your scripts, you can tune the agents, you can tune the scenario and the controller. For example, I also had to tune the controller and the scenario settings, because when 2 million users are running concurrently, and Neload has a feature to lively show the current behavior of the test, the average response times, the transactions per second, etc. So it's a lot of live data is going on. Actually, when the first ran the test, it was just the controller was just so slowed down at nearly 1 million users. So I need to tune the controller first,
right?
Because there is so much network traffic going back live at one time from all the agents towards the controller. So one thing that need to tune was to kind of throttle down the network push back from the agents to the controller. There was like a feature. Most tools have such a feature that you can follow the users live. So you can see which transactions they are, which step they are doing at the moment.
Right.
You can disable that. And by disabling that, it was a tremendous save on live network traffic. So there was already a big win.
Mm-hmm. And I remember when we had the discussion in Santorini about it, that we said it would be smart for tools to say, hey, you are running a 2 million user test. You probably don't want to see every single user live.
Yeah.
That means you may want to disable this feature by default, or at least give recommendations on settings you have right now that are, give advice on better defaults or settings based on your workload configuration.
Yeah. Yeah, also something that was also really important to do, because if something occurs on the platform you're testing, let's say service is restarting or whatever, and you get all the users get a small part of errors at that moment. If you're running with 2 million users or even with 100,000, all the users can get the same error at the same time. Mm-hmm. There were tons of errors per second you're generating. That caused, every time when that happened, it caused a lot of agents to crash at that moment, and the controller to be just unresponsive. So tuning was necessary on that part too. So just storing a limited amount of errors per second, and that also helped me to be able to cope with just sudden spikes of errors. Something you would just encounter when you have a heavy test.
Yeah. Are there, so besides that, besides the load agents, figuring out the capacity, the number of agents you need, optimizing the whole controller and your runtime settings, was there anything else or any other lessons learned from a testing tool perspective that you can tell us about, or is that it?
Well, yeah, I haven't talked about what you can do on the scripting part, because you have to tune your scripts too, because the scripts are actually the core of your test. The scripts are run by the agents, and there is some stuff that you can do on your scripts to limit the load actually on the agents.
Like what, for an example? Any recommendation? Lessons learned?
Sure. If you have many scripts, actually all of performance testing scripts, they have extractions. You have to get a variable value and use it in the next request. Most of the tools use regular expressions, or you are able to use regular expressions for that. you have to use them with care because they can be really CPU consuming. So don't use like a lot of wildcards in them. They can really cripple the performance. Consider proper assertions. Don't use them too many. I'm usually a really big fan of having a lot of assertions all over the place, all over your script and request, so you can verify a lot, so you know when there's an error occurring. But for a heavy test, yeah, might be able to just get a little bit less of the assertions to save some resources too, because they can be really consuming.
Right.
So other things that you consider is decreasing the think time in your test. I'm never a fan of this, also not for a heavy user test, but decreasing the think time means you will have a smaller session time of your virtual user. That means you have less concurrent users running, and that also means less memory usage at one time. You can do that too.
It's funny you mentioned that one because I was just thinking myself, aside from that there are a lot of considerations that you have to take when running a load test, such as, there was a question that came up once a long time ago, like, can you run a heavy load with one user in JMeter? The answer is yes, no think time.
Sure.
Right, but it's zero concurrency, and understanding what kind of test you need to run is a huge part of that, right? You can say the product managers could come to you and say, we want to have 2 million votes, right, in an hour or in 7 minutes. All right, but what's the concurrent? The questions you as a performance engineer, performance tester need to ask are, what's the concurrency we're expecting to have in this? And then when you get to the scale that you're running at, you do then run into the issues of, can you actually test at that concurrency? Because what's that going to do the amount of generators that you're going to need? And is the controller going to be able to, if you need 2 million concurrent, that's going to be taking the challenge you had already to a whole different level.
Exactly.
Right?
Yeah.
And there may still have to be some real world shortcuts you have to take just in order to get some sort of resemblant test done. But also things you'd have to consider, which you always have to consider in any test, but also just kind of come to a whole different scale at the scale of testing you're thinking about. There's conceptually, do I run a test from an internal generator or external generator? How many locations am I running from? Am I running it from different cloud vendors so that I can make sure that as this goes on, because in reality, your users are going to be coming in through different angles. It's not all going to be coming in through an AWS DNS or pipeline, I should say. So you really have to start thinking much bigger scale. How do we distribute that load? Internal, external, what different geolocations is this going to be, from, if this is, if this is like obviously, a single country show, then you don't have to worry about too much of geolocation. You might want to consider some, but it just takes all these decisions become a lot more relevant and a lot more important. Because so what were some of the, sorry I cut off on that one piece though, but I think that was a really, really important part that you mentioned about the concurrency. What of those things that would normally be, yes, we need to consider that, we need to think about that, but which one of those kind of became really, really strongly focused, or really, really high priority, I should say?
Yeah, well, first of all, I agree 100% with you, what you're saying. And that's actually always the case. I mean, being really as realistic as possible, that's always a good approach for your performance test, I would say. As you said, you can do a lot of transactions and you say, okay, we need 2 million bots in an hour, and you just generate it with a low amount of virtual users. Yeah, you can probably do that, but you are not doing the right concurrency. And that's what I want to achieve in this test too, because we were doing the web application was about WebSockets. So WebSockets were involved, and that means that every user sets up a connection there, and every user has just one simultaneous connection at one time to the application. And as we all probably know, connections is really maximum connections. It's usually a very common performance issue. Max number of threads, max number of connections, or whatever, things like that. So when you want to tackle that, you just need to simulate it. So that's why I also always try to have the right number of concurrent users as you can expect in a peak moment in production.
Right.
Does it answer the question a bit? Because I thought the question was kind of different along the way.
Yeah, no, it is. It really was more of a discussion or just me thinking aloud, I guess, about some of the things you would normally consider during a load test.
Yeah.
Which seems like, okay, we consider this, but now it's like, this is even more important to consider. Because a lot of times people, like in the past, let's just take the internal versus external load generation. Right? There are use cases for that, right? You can have, maybe your users are internal, or maybe you don't care about testing from the internet. You're just testing the traffic rate on the servers, right? Everything that you set up in a performance test is based on what your goal of the test is to test, right? You have a theory, you have it's kind of a scientific approach. So what do we need to test? Test for that. But when you're testing at something at this scale, all these things that are sort of optional or sort of maybe talking points become critical, is really, I guess, what my thought process was there. I
actually have a very good example for that. That's usually you can take a shortcut when you do test the application or website. You can, in 99% of the time, you can just avoid doing all your CDN objects. Like they're coming from the CDN,
right?
It's not hosted by you. Someone else is hosting it, and they're good at it, so it will be fine. But I've run into very large-scale performance tests which rely on CDN, and actually ran into issues on the CDN objects.
Yeah.
So for large-scale performance tests, I would always say just include all the objects there are, even if it's CDN, because you can run into issues on them as well.
Yeah, like I remember the discussion we had in Santorini, and I remember a couple of years back when we, on Black Friday, we always analyzed how websites were doing. We found a lot of websites that were rate limited by their CDN provider, because either they were rate limited because they thought it was a denial of service attack, or it was a rate limit because they just didn't pay enough money, or it was not part of the contract, and all of a sudden they were rate limited and the content wasn't delivered anymore. And is that what you're talking about?
Yeah, exactly that. Because I've ran into those issues as well. When I thought the first time, I think maybe not so. Maybe it's not necessary to add all these static objects, because it can be a real saver on network, on the load generators, etc. But when I included them, we actually ran into issues on those third parties or on the CDNs, because they actually have quotas and limits. Even CloudFront, for example, there's a limit of, I think it was 1,000 requests per second or something per region. You can just hit that easily with high volume users.
Yeah.
So if you just don't tune that on your CDN provider, you only will run into it at your peak, and then you're screwed.
And then people come to you and say, "Didn't you test this? We told you exactly what was expected." Yeah.
But that also brings up two ideas. We talked about CDNs, and you mentioned third party, and I think third party is really important to just make sure we explicitly state, because you might have like a Google font, right? You might have a tracker, right? This isn't necessarily a CDN object, it's a third party object, and that can come to bite you in as well. But also, if you start talking about all these CD elements, all these CDN elements, all these static elements, I would really want to go back to the product team and say, hey, if you're expecting 2 million people to vote in the next 10 minutes, we need to get rid of everything we don't absolutely need on this page. If you think back to,
Exactly.
I'm not sure how familiar you are with what goes on in the United States during the Super Bowl, right? So they have these, the Super Bowl, the big football event, American football event. And it's, advertisements run and websites crash, right? But one of the things a lot of successful companies have done, some have tried the approach of let's just really increase our hardware, right? And that's somewhat successful. But the more successful ones, and we see a lot of the car companies do this, is they strip all the junk off of their page. If they're trying to drive you to their homepage for the new, let's say, Volkswagen Passat or something, whatever it is, they get rid of the build your own feature. They get rid of all the features on the page, and they just have the main content they're trying to drive you to. They get rid of all the fluff. They get rid of all the extra fonts. They get rid of all these things. So I guess this brings me back to the question is when you're talking about CDN in context of this test, was there a lot of fluff on this? Were they trying to cram in a bunch of things that were unnecessary for the voting app because they wanted it to be really flashy and cool looking, or did they keep it simple?
Yeah, well, it was actually, to be honest, very, very simple.
Oh, good.
Because it was an app, a native app.
Oh, okay.
Just when you open the app, it just starts a WebSocket connection. It does some stuff, and it retrieves some static objects as well, which are placed on the CDN, which we had issues on basically at the first place because there were too many objects retrieved at the same time. So they were using CloudFront, and CloudFront ran into rate limiting. So it was really, really helpful that we tested that and tuned that. So for these native apps, there are not a lot of waste on it anyway, because most of them are very simple static objects or API calls, or in this case, web services.
Yeah.
But there was another example, basically, on a project that was actually with 500,000 virtual users, and that was also actually for TV show, but for totally different one. They were relying on a static object on a CDN to retrieve, to actually do the polling. So they were not using WebSockets or whatever, but they were just polling on a JSON file on the CDN every 2 seconds to get the live state. But imagine 500,000 users doing that.
Yeah.
There were 250,000 requests per second on CDN from different regions, of course, but still, because it was an app in the Netherlands, they were not really relying on different regions. It was all the same region. It was it was not really much geographical spread. So what happened is that we not even just got into rate limit, but we even were stressing the edge nodes that were located in the Netherlands. So the edge nodes, they fell apart actually.
So you stressed, so the capacity in your country wasn't even capable of the CDN provider to handle the load. So that's interesting. Wow.
That happened. Yeah. So eventually they changed the polling, the polling part. So let's not retrieve it 2 times a second, because it's quite a lot. But the developers expected, it's the CDN, it's cached. Even if it's cached for 1 second, they should be fine. But
it's just like cloud resources. They're infinite and free. It's a CDN.
I think, Brian, that's actually a good point, right? While maybe these cloud services are, scaling and they can handle the load, but it's not free, because eventually somebody has to pay for it. Nothing is for free. That's why you always have to factor that in as well. Yeah.
Hey, one other question. This one hasn't come up yet, I don't think. But I'm just wondering how you might tackle it. I haven't seen evidence of this happening yet, but one new scenario I'm expecting to see in terms of load and performance degradation is with everybody working from home right now. Right? A lot of people, or quite a large amount of people, are connected on their company's VPN. Right, and we all know corporate VPNs are not built for high bandwidth because they have some remote workers. A lot are in the office and they don't need the VPN. But even still, you might be going to a VPN. At least here in the States, I might be going, half the country away to a VPN, adding all that latency. Then I'm going through the corporate VPN, any sort of network security policies being applied to what's going on. When you think about if this test were going to be run in today's, quarantine type world, where you have these considerations of possible slower bandwidth and VPN, what could you do to accommodate that? Would it just be setting some bandwidth throttling on the load generator, or, would it even be a consideration? I guess we'll start there, and what might be done.
So what you actually say is that you add an extra network route, so you add a VPN to the route to the application, or you're talking about testing the VPN service?
Well, you couldn't necessarily test the VPN service because it can come from anybody's and anywhere, and we don't know the settings. But considering the impact of performance that might occur if people are using their VPN, like let's say, again, I'm making blatant statements here, and I think this is part of the things that would have to be determined and found out. But if, let's say, the voting was during the day, let's say it was a World Cup, something going on with the World Cup, and there was a thing, vote during the day. So everyone's working, and then they go ahead and vote while they're on their corporate VPN. Right now, the response times of the application are going to slow down, not necessarily because of the back end, because although that could happen, but because they have a throttled network connection, everything is going to slow down some more, which means, number one, their performance is going to degrade for the end user. Yeah. But that could also cause some either beneficial or detrimental bottlenecks, because if everyone's slowing down, things aren't getting quite as fast. And I just wonder, like, if we're talking about, and it might just come down to the plain simple theory of, does VPN in general slow down your network bandwidth? And if so, is that another thing to consider when running these kind of tests, if you're thinking about something in today's world right now where we're at?
Yeah. Well, I think basically you're talking about network emulation.
Yeah, I guess, yeah.
So when you test your application, you have to consider actually the network types of your users. So for that, you can, most of the tools, a lot of tools have some kind of network emulation included, in which you can throttle the network bandwidth, or add latency, or even add some packet loss if possible. Mm-hmm. And I would say if a lot of users are on a more like crippled network, that could eventually harm your application as well.
Yeah.
In the sense that response times increase, and that also means that on the server end, there is an increase too, because the connections are open longer.
Right.
There is at one time there is a lot more concurrency in terms of concurrent connections. Yeah.
And also you need to keep more data in the buffers before they can be sent out.
Exactly. It's all the whole pipe. It's open. So you have more concurrent connections, the buffers, the memory, and all the network components. They're getting heavier. So yeah, it makes sense to simulate that, but it's not even for only VPN. It's also for your mobile users.
Right.
Many mobile users are on if they are on slower network, even packet loss involved that can have a significant impact on that. I haven't done this actually for my 2 million user test because I found that a bit too heavy.
Yeah.
to include even network emulation. Would be cool though to do that. But the network traffic was really low. So I didn't consider that as a real risk. So I didn't get into the troubles of adding that. But if you're having testing a web application, it is really worthwhile to just give your test the extra edge and add network emulation. Yeah, I agree.
I think that's one of the toughest things. You mentioned before being realistic with your test. And I think that's one of the biggest challenges in designing a test is the more you think about being realistic, the larger the scope becomes, right? Because you suddenly start thinking of, this aspect, this, like so many variables. And that's always just been a challenge, at least back when I used to do performance testing, it was always such a challenge to try to get that, try to take that realistic approach while actually trying to get a test done, because the more you think about it, the more the proverbial can of worms opens up, and you'll sit there for you could sit there for 2 months setting up a test then as you think more and more about it, and meanwhile the test needs to be executed.
It's always the balance, right? Between being as realistic as possible, trying to mimic the users as good as possible, because that gives you the most honest, real results.
Right.
If you take shortcuts, take them wisely, I would say.
Every shortcut should be thought about and considered and evaluated.
Yeah.
Hey, Joerek, I remember, and I don't remember the details, but I remember this topic was started some discussions back in Santorini. Something about DNS. That some lessons learned on DNS. I remember that. Can you remind me of that and fill us in?
Yeah. That's actually a bit of a technical part, but if you're doing a heavy performance test, you're probably testing an application that runs on the cloud or relies on cloud services like CDNs or other or cloud platforms. And as far as I know, practically all of them rely on the DNS system, the DNS behavior of balancing the users by using the load balancing. And when you're doing a performance test, it can be really hard actually to tackle this. So it's really important that you know how your the platform you're testing is dealing with this DNS load balancing, because for sure it is dealing with that. And if you just don't do anything, you take the test tool out of the box, is it Neoload, JMeter, Load Runner, doesn't matter. The DNS, I would say, simulation is actually pretty bad. So what will happen is your load generator will cache the DNS response, and most of your users, or all of the users, are just going connected to the same IP address all over again. And you're testing just a small part of the application. It's not realistic. So, some things that I do are for these heavy tests. What I do is I just use a self-hosted local DNS server on the load generators. So I've installed a local DNS server, and then I override actually the TTL. So usually the TTL for these cloud services is like 60 seconds, which means for 60 seconds, all the users are connected to the same IP address, which is not realistic, but because all the users are doing that. So by overriding the TTL, you're just forcing the load generator actually to constantly retrieve the new IP address list and connect to all of them. Because if the application or the cloud service is just forcing you to a different IP address because it's scaled up, or it just wants to avoid a heavy edge node or whatever, you want to follow that behavior like real users would do, because every time a new user is opening the browser and going to the website, it's doing a DNS record, DNS request for that user. And so that's really tricky.
Yeah. So that I understand this correctly, you had your 800 agents, load generating machines, and then on all of those you installed a local DNS, and this one had a TTL, a time to live of 1 second versus 60. That means every second you requested, you got the new DNS entries.
Exactly. Yeah.
And this actually forced the load generator itself to actually refresh the DNS. That means the testing tool needs to understand this as well. So the testing tool actually then gets served from your local DNS server IP addresses with a time to live of 1 second versus 60 seconds. I get it. Yeah.
Yeah. And of course, you have to tune your JVM that it's not caching DNS responses, of course. But there's another trick that you can do actually, because usually your load generators are located on maybe one or just a few ISPs locations. So if you use AWS or the Google Cloud or Azure, whatever, it's still not really geographically spread. What you can also do is also what I did in the test. If you want to mimic a more geographically spread users, you can use a DNS server on that machine with a different geographical location. For example, if I have a load generator which is located in Amsterdam, but actually I want to have it simulated from Berlin, I can use a DNS server which actually is in Berlin, and then the cloud service would think the users are located in Berlin and responds with IP addresses of edge nodes which are both or in Berlin.
So technically, I'm not the expert on DNS. Do you say that when you install your local DNS, you basically give it the geolocation, you override it, or you define the geolocation as being, let's say, Berlin, and therefore the cloud services believe you are from Berlin? Or are you talking about there are some DNS servers out there in Berlin that you're using?
The last one. Yeah.
The last one. Okay.
So if you're using a self-hosted DNS server, the CDN would think you're actually in the location where it actually is, most probably.
Yeah.
If you use a third-party DNS service, and there are lists on the internet where there are open DNS servers with their location, even with their city. And if you use that DNS server on the machine where your load generator is installed on, then that machine would do the DNS request to the DNS server in a completely different location. Then that DNS server will do the actual request to the CDN, and then that CDN would think, the user is using that DNS server, so it's probably located there. I would respond with an IP address list or IP address that's close to the user, so the user would have the lowest latency.
Yeah.
And by doing this, you can kind of trick the test, trick the application that you're in a lot of locations, and so you don't. Yeah, that's a bit of a trick actually to spread load generators on geographical locations.
Yeah.
But it's not important really to have a load generator in that location, or
I understand.
You want to test from a location, but you want to hit the different edge nodes. You don't want to be the edge nodes you're hitting to be a bottleneck.
Yeah, that's very cool. Hey, Joerek, I know that there's also a blog post that you wrote as one of the proceedings for Neotys PAC. We want to make sure we link that, and I think I assume in the blog post you're going through some more details, so we may not want to steal all of the thunder. We want to make sure people are reading this as well.
Yeah, the blog post still has to be published, And in the blog post, there's a lot more explanation on how to trick the DNS actually, and how to set it up in your performance test to,
That's
get this
amazing.
extra edge of being more realistic.
Yeah. I got one last question for you. And because I know we both said earlier, we want to make sure that our better
Do it
halves
now.
are not waiting too long for us for dinner because it's late here in the evening. But so what you've just told us, these are very special types of load tests. You are testing for a big event. It's a one-time thing. It's not possible to test, let's say, by doing, let's say, shadow traffic in production because you don't have production traffic right now, or things like that. So these are very specific, very special tests. Now, Brian and I, in the last couple of months and years, we've been talking a lot about shifting left, testing earlier, testing more frequent, smaller tests, integrated in your CI/CD pipeline. Is there anything we can learn from these tests to shift left in order to avoid these tests, or are they just completely two different disciplines? Where you say, yes, we have to shift left to find things earlier, but you still need these large load tests in a preparation for a big event.
Yeah, I really would love to say that, you can go left with this type of test, and this is another approach to tackle this. But I would not say, I would say you would really need this kind of full acceptance test to be really sure that it's capable of. Because as I said, there is the high load, you can never test that in your pipeline easily. I would say not never, but it's not easy to do. The CDN part, which can have troubles, it's probably not part of your pipeline, or you cannot just tackle that in a small scale test. The concurrency problems you might have throughout the whole application is very complicated to test, automated in your pipeline. So with these heavy tests, I would say, probably you can test your small services that you're creating already. So along the pipeline, along the releases, you can tackle differences. That's always good. But in the end, just before go live, I would always say, you just have to do it to be sure.
Yeah, that makes sense. Yeah.
I was thinking too, you can't really, this isn't the case where you can slowly trickle traffic to the new feature, because this is almost an all at one, so it's interesting.
But and actually I still want to encourage everyone to still test their application as it is in the traditional way, as a full acceptance test, because when everything is put together and you test with the real load, there are so many other problems you can encounter.
Right.
So,
and I think even those tests, they become a decision point, right? Like in your specific case, that 2 million user, right? That's we'll take a step back, right? A lot of times people will say, we'll run performance tests against my services. We'll do a lot of shifting left and run for capacity and everything on the specific services, so that we know if we test every single service, it should all work together, right? Which we know from history is not always the case. But I think a lot of the, let's call it maybe more agile focused performance testing is testing the changes that are being introduced and then observing in production and then fixing, right? This whole kind of feedback cycle. And so when you have a situation where it's normal traffic, a normal scenario, you can take calculated risks, understanding everything that's going on and everything that you're willing to risk to push something to production without having a full end-to-end test, because maybe it's your steady standard load, Maybe you're going to do a blue-green deployment or something or a canary release where you trickle in your users. You could do slow observations. But again, in considering what that traffic is going to be and what the real life scenario is going to be in the situation you have specifically, I don't think there's any way you can argue that, oh yeah, we're just going to test everything before production and then assume 2 million users end to end are going to work. So I think a lot of times that consideration has to be made, and there's in the performance world, there is a lot of give and take and decision points being made about how frequently do we still run the end-to-end tests, right? They're still obviously very much important, but we're not in the waterfall day where you can hold up a build to do an end-to-end test every single time. So it becomes part of that decision point. But I think, yeah, in that scenario that you're talking about, that's an obvious, you have to.
Yeah, there's still so many applications that are event-based, where it's just maybe a one-time occasion where they have a lot of load, a lot of users. It's not like a real ordinary day where you can learn and grow and tune and back and forth. Yeah. So that's the difference.
Yeah. Awesome.
Yeah.
Joerek, in the beginning, before we started recording, you said, I don't even know if we can talk for an hour. Well, almost an hour later, right? We're still here. And I believe, though, so Joerek, I would love to have you back because I know you're constantly out there. You're constantly doing projects. You learn a lot on the job that you want to share. Hopefully, that would be great. So maybe get you back in a couple of months and get another episode of extreme load testing.
Yeah, or totally completely different topic maybe.
Yeah, or maybe something
performance
different.
related though.
Yeah, of course. Yeah, sounds good.
Sure. Well, thanks for having me.
Thank you for taking the time.
Give me the opportunity to talk about this topic.
Yeah,
it's a pleasure to have you. And if anybody, do you do any of the social media you would like to put out there for people to follow you, whether it's LinkedIn or Twitter or anything?
Yeah, you can follow me on LinkedIn. That's probably the best social media channel I use.
Okay.
we'll put the we'll put the link.
Joerek, connect me.
Yep. And if anybody has any ideas, topics, or anything else, or if they, want to come tell us some stories as well, you can reach out to us at pure_DT on Twitter, or you can send us an email, pureperformance@dynatrace.com. And just thank you, Joerek, for being on the show. This was great fun today.
Great. Well,
all right. Thanks, everyone.
Go back to your quarantine part.
Yeah.
Good luck with that.
Good luck, everybody. All right. Thank you. Bye-bye.